Hello everyone, I am Abhishek Upadhyay. I am data analyst trainee at Trainity. Today I am going to present my project 8, which is ABC call volume trend analysis. So let me open my report, project report. So my project report. This is my project report, and in this project we have to deal with data set that span 23 days data, including some information like agent's name, agent ID, queue time, the time of call, duration of call status including answered call, transferred call, and abandoned call. So here we have to provide some data analysis task to drive out some insights on the basis of these tasks. So let me open my Excel sheet and report also. So in to calculate this project, my approach is I first download the dataset from the Trinity dashboard. Then I used count blank function. I used count. This is dataset. I given the name of as raw data. I save this data as a raw data. So now I have to check whether this data containing any null value or any missing value. So for checking that, I used count black function, and but after applying this using this function, I found that there is no any blank cells in this data. So I simply copy all this data and convert it into tabular form and save the data tabular data, the name of final data. Also, I added one more column, additional column by separating the date and time column. So now I will perform all the task on this tabular data. So first task is in first task they are asking what is the average duration of call for each time bucket. So we have to calculate average duration of calls for each time bucket. Basically there are time buckets given. Time buckets mean time interval like 9 a.m. to 10 a.m., 10 a.m. to 11 a.m. and so on. And these are the time interval between 9 a.m. to 9 p.m. for day shift only. So for each time bucket, we have to calculate calls, number of calls received. So the data given is for 23 days. So for task A, we need to calculate average duration of all incoming calls by agent for each time bucket. So to answer this, I used pivot table and put. So let me show you. To answer this, I use pivot table. This is my pivot table. Let me show you the field. In pivot table, I put a time bucket in rows column. Sorry, rows section. Then call status in column section, and then call second is in value section. Then by default it will come as sum. But I go to value field setting and then go to value field setting and then converted it into average because we need average. And if we want to round up the value, we can go to here and then select required value as per our requirement. If the decimal place, if we click 0, then it will be 203 suppose, but here I taken 2 up to 2 decimal place, that's why it's 203.33 and so on. So this is for I applied pivot table for all the data, so that's why we can filter here for our. If we want to see all data for all status, then we have to select all these things, and if we want to see only answer calls status data, we have to simply select answer. Also we can also insert slicer for more conveniently filtering the table. I also added a bar chart here. So we can see the highest value of average call answer in second is 203.41. Highest value of average calls answer in second is 2045 time bucket 7 p.m. 90 20 means 7 p.m. to 7 p.m. to 8 a.m. 8 p.m. We can see here total average number of calls duration is 203.41 seconds. So for the least, this value is 192.89 for the time bucket 12 p.m. to 1 p.m. and this value is 192.89. This is for answer call only. If we want for all the status, that is for if we include an abandoned answer and transfer call, then we can simply select all the values. Yeah, now here the data will show for all the calls which are abandoned, answered and transferred. So this is my task 1. And if we calculate average call duration between 9 a.m. to 9 p.m., then it will come 198.62, or if we round up the value, then it will be 199 seconds, which will use for our next task. So now come to the task. Here I mentioned the same thing on the same way on my report also. We can use PPT, but I here used MS Word, and then later I will convert this report into PDF. So I utilize Excel functions like pivot table, chart slicer, average, and some formulas. So now comes to task 2. In task 2, we have to answer, we have to create a chart or graph to show the number of calls received in each time bucket. In task 1, they are asking only for answer calls, but in task 2, we need calls for all the calls, including abandoned, transferred, for each time bucket. So say on the same way, I already applied filter here. If we select all these filters or these conditions, then we have to find the data for all calls. So let me show you. Yeah, this is my second task. I insert a pie chart for this also. On the same way, we can apply pivot table. Then in order to convert number of calls, use we have to utilize a unique column which have no duplicate. So according to me, the final data having a column called customer phone number. The phone number can't be duplicate. That's why I taken this column and put this column into pivot tables value field, and then change the value field into count. Let me show you how. Yeah, so I put it call status in filter, then time bucket in rows, and number of call customer phone number in value section, then convert the field into count. So here comes the total call count. So we can see the total call count is maximum between 11 a.m. to 2 p.m. if this is for answer call, if we want to see total call count, we have to select all these. Yeah, now we can see total call count is maximum between 11 a.m. to 2 p.m. 11 a.m. to 2 p.m. This. So if we see these values, if we add these values, these are the maximum. So here comes total number of calls, which is 117988. Now in the result, I also mention that maximum calls received against time bucket 12 p.m. to 1 p.m. This is for answer calls only. If we select answer calls, so maximum call received are between for 12 a.m. to 1 p.m. This 9432, which is 11.44% of total number of answer calls, and minimum calls received between 8 p.m. to 9 p.m. This value, which is 2870, which is 3.48% of total number of calls answered. So I mentioned here that I use utilize pivot table. I put the time, the same thing I mentioned here. So I inserted created pie chart, and if we want to include abandon and transfer call with answer calls, then we can also do on the same way. So for this I created a cluster column chart. So we can see maximum number of calls are for time bucket 11 to 12, 11 a.m. to 12 a.m. 12 p.m. So now it's here comes our task 2 completed. Now come to the task 3. Yeah, task 3. So before starting doing task 3, we have to consider some assumptions, which are the task 3 is manpower planning. So manpower planning for 9 a.m. to 9 p.m. support. So in this task, the current rate of abandoned calls is approximately 30%. We can also see this. The current rate of abandoned call we can see in our I calculated in third 3, yeah. So this is abundancy percentage for 23 days. So we can see it's approximately 29 point something. I rounded up the value, so it will come to 30%. We are assuming that the current abundancy rate is 30%. Yeah, this is our task. So 30%. They are saying that we should propose a plan for max manpower allocation during each time bucket from 9 a.m. to 9 p.m. to reduce the abundancy rate from 30% to 10%. So if I can say, we need to calculate the minimum number of agents required in each time bucket to ensure that at least 90 out of 10 calls are answered. As per the current scenario, if 100 calls received coming, then agents are only able to answer 70 calls. But they are saying that we have to reduce that abundancy rate up to 10%. It means that we agents uh, need to give the answer of at least 90 call coming from 100 calls. So we need to calculate the number of agents required to achieve this. So here, let me show you my Excel sheet. So here I calculated. Firstly, this is already I calculated in task 2 also. These things I calculated in task 2 also. Yeah, these things if we select all the value, yeah, this is. So again on the same way we can calculate the things. So assumptions are, these assumptions are also applicable for task 4. So let me show you the assumptions. Agent's working hour per day is 9 hour. Lunch and if snack time hour are 1.5. So it means that on floor work hour will be 7.5, and working day in a week 6 day, month days are 30, unplanned leave are 4. It means that agents are one agent can one agent will take 4 unplanned leave in a month, and work day per month is, if we calculate, so the actual work day per month for one agent is 22. If we calculate, we consider as the working days and monthly days and unplanned leave, so it becomes 22. So in the assumption also it's a given that uh, yeah, in assumption it's a given that the actual working hour is 60% of 7.5. It means that 4.5. 60% of 7.5, it means that 4.5. So total time spent on call 4.5. 60% of 7.5. So total time instead of cup, this is in hours, so we have to convert this into second, because all uh, this this is in the form of second, so that's why I converted this value into second. So the second number of total spent time will be 16200. So data set given having data of days 23. So data set having 23 days data. Here it's mentioned that it's earlier mentioned in the top of the project description that this data having a span of 23 days data. Yeah. So data set is considering span of 23 days. So these are the assumptions. Now proceed to task 3. And the same pivot table I copied here. This is for total calls. This is for average call second. Now I calculated required values. So these values are for 23 days. We have to record per day data in order to analyze how many agents more agent required to reduce the abundance rate up to 10%. So in order to in order to calculate per day data, we have to divide this data by 23. So abundant data for 23 days is 5, abundant call for 23 days is 5149. If we divide this data by 23, then we have to find out the abundant calls per day. So this is abundant call per day. On the same way we can calculate answer called and total calls per day. So if we want, we can calculate percentage abundant per day. So abundant calls per day are 224 and total call per day are 417. So percentage will be 224 divided by 417. So it will come 54%. On the same way, this is for time bucket 9 to 10. For first time bucket, we can calculate these data for all the time bucket on the same manner. So now it's completed. Now come to the our actual task which is required to reduce the abundance rate up to 10%. It means that we have to achieve 90%. So to achieve 90%, this is our per day data, total calls per day. So if we want to attach to achieve 90%, we have to calculate data for 90%, considering 90%. So I have divided I have multiplied this value by 90%. So it means that Q4 multiplied by 90%. Yeah, so 417 multiplied by 90%. It means that per day answer call required to achieve 90% is 375. For this is for single time bucket 9 to 10, 9 a.m. to 10 a.m. If we consider time bucket 9 a.m. to 10 a.m., then the per day answer call required to be achieved means we have to answer 375 calls per day for time bucket 9 to 10. On the same way, we can calculate for other time buckets. So now we have to calculate this value. Currently, how many agents were available to complete these tasks? So come to the assumption point. So if if we calculate average calls handled by an agent per day, then we have to divide this value by this value. So I earlier calculated in assumption section the total time spent on call in second will be 1620. How it's come? It's a 4.5 divided by 3600 because 4.5 in hour. So if we convert 4.5 hour into seconds, so it will come 16200. So this is 16200 value. Now we have to. This is actual working seconds. Now average call second per day will be 199. You can see pivot table 2. So this is average call second per day, which is 199. So if we want to calculate how many calls received by a agent per day, then we have to divide this value by this. So this is at approximately 81. All values are in approximation. I rounded up the value, so that's why there will be a little bit difference. So the average call handled by an agent per day will be 81. So average call handled by an agent per hour. This is for per day, and if we calculate per hour, then it will be this divided by this because an agent effective working hour is 4.5. So that's why this 81 will divided by, sorry, yeah, this 81 will be divided by 4.5. Yeah, right. So it's come 18. This is average call handled by an agent per hour. So data set having data for 23 days, it's already told you. So now we find that average call handled by an agent per day is 81. So now come to the our analysis. So agent currently available. If we did not consider as of now, did not consider this 90% achievement, then the agent currently available. So we have to divide this total value by 81 because an agent handling 81 calls per day. That's why total calls are 193 per day. Calls are 193. If we talk about a particular time bucket, that is here I ask talk about 9 to 10 time bucket. If we see total number of calls for for one day is 193, sorry, 417. And this is total calls per day if we include abandon and transfer, but we have to do the analysis on received call, answered call. So total answered call per day in case of time bucket 9 to 10 is 193, and one agent can answer 81 call in a day. So number of agent required will be 193 divided by 81, that will be approximately 2. So on the same way, we can calculate number of agents currently available for other time buckets. So if we add all these values, then it will be 44. It means that as of now 44 agents are available to do the job, and in this case if 44 agents are doing if 44 agents are answering the calls, then the availability rate is 30%. Now as per the task 3, we have to reduce that abundancy rate to 10%. So now we need to calculate additional number of agents. So if abundancy rate is 10%, it means that we have to achieve 90% of answer calls. So this is how, if I talk about a time bucket, 9 to 10 time bucket, then number of answer calls is 193, and if we considering 90% efficiency, then the number of calls will be 375, which is total calls multiplied by 0.9. 0.9 means 9, if we convert 90% to fraction value, then 90 by 100 means zero point 0.9. So that's why total calls are 417. So this is for achieving 70%. But if we want to achieve 90%, then this total call will be multiplied by zero point 0.9. So this will come 375. Now one agent can answer 81 calls. So if we want to answer 375 call, then the number of agent will be approximately 5. So the difference will be 3. Here the difference will be 3, but actually these value are in approximation. Let me show you. If we, yeah, so this is actual, the actual value is 2.37, and here it's 4.6. So if we calculate the difference between this value and this value, then the value will be 2.225. But here I consider approximate and rounding of value, that's why it's coming 2. If we round up the value, then it is 2. So on the same way, we can calculate this data for other time interval, other time buckets. So the additional difference means these are the additional elements required to achieve the 90% target. So total number of additional agent required will be 13. So a this is a line chart. Now our task 3 completed. I here mention inside also the same way I mentioned inside in my report. Maximum manpower required between 9 a.m. to 12 p.m. due to high call volume. We can see in the here we can see now 13 more agents required to answer 90% of incoming calls. Between 9 a.m. to 12 p.m. call is abundant range in maximum. From 3 p.m. to 7 p.m. no extra manpower required. We can see here in difference that no extra manpower will required between these time interval. Let me show you. Let me show you Excel sheet. Yeah, this is, yeah. So this is in case of 30% requirement for 15 between 3 p.m. to 3 p.m. to 7 p.m. If we consider 30% abundancy, then agents are required 4443 respectively, and if we consider 90% efficiency, then there is no change in number of agents. That's why here I mentioned that between 3 p.m. to 7 p.m. no extra manpower will required. Here comes our task 3 completed. Now come to the task number 4, which is our final task. So in this task, now we have to consider night shift also, and there is a condition also given for night shift that if we receive 100 calls in day shift from 9 a.m. to 9 p.m., then consider 30 calls in night shift between 9 p.m. to 9 p.m. to 9 a.m. It means that in night shift number of calls coming are equal to 30% of number of calls coming in day shift. So here let me show the Excel sheet again. So here we can see if we calculate number of calls, total number of calls for per day. So total number of calls for 23 days is this. But if we consider per day data, then the total number of calls will come 5130. So this is total number of calls coming between 9 a.m. to 9 p.m. As per the condition given in task 4, total number of calls coming in night shift is will be equal to 30% of this 5130. So 30% of 5130 will be 1539. So these are the assumptions I already told. So I this is time taken on an average to answer a call in second. If we convert this into hour, then it will be 199 divided by 36. That will come in convert in hour. So total working person required per day to achieve 90%. We can see calculation in task 3. For 90% achieving, the total number of agent required will be 57. So this is 57. Total com volume in day shift between 9 a.m. to 9 p.m. 5130, and for if we consider night shift, then the calls coming in night shift will be 30% of 5130, that is 1539. So additional hour required. It means that 1539 more calls are now we have to handle. So for these number of calls, 57 agents required, and 1539 more calls required to handle. Then additional hour required will be this 1539 multiplied by this value, 1539 multiplied by this value. So this will come 77 hours. So additional head count means additional agent required. So 77 divided by 4.5, that will come approximately 17. So it means that if we consider night shift also, then 17 more agent will required. So earlier to achieve 90%, if we consider only day shift, then agent required is 57, and if we add night shift also in that support, in our support, then we have to require 70 more agents. So total agent will be 57 plus 17, that is 74. So here comes our task 4 also completed. So and the same way I prepare my report. Yeah, here I mention all the calculations. So that's it. Now, thanks to watch this.